We have a two signal. One look like this, and another signal look like that. And what if this signal overlap this signal? Can you do that? Yes. Yeah, try. And then increase the magnitude. Yeah. Okay. You cannot hear 1 kilohertz. Okay. When you move down, you can hear. Slowly move up. Stop. Can you hear 1 kilohertz? You can hear. I cannot hear. Oh, because I'm old. Oh. Sorry about that, huh? And why don't you move this 1 kilohertz over here a little bit slowly? The frequency, change frequency to 900, please. You can hear. And what about 800? You can hear? Okay, what about going up to 1100? And 112. You can hear, right? Right? Okay. Can you increase the noise a little bit more? More? Okay, you cannot hear, right? Okay? You can hear. Oh. Increase more. You cannot hear, right? You hear?
It depends on the direction.
Okay. Okay. Why don't you move this one slowly over here? Yeah, okay. Okay, go. You can hear, right? Okay. So that is masking effect. You cannot hear. Okay. And move a little bit more. This one. Here, right? Okay. So it's depending on the magnitude scale and the frequency location, we can hear or we cannot hear. So it's very non-linear, right? So our auditorium system is very non-linear. Okay. Okay. So now the frequency content, frequency characteristics of our auditory system exhibits very interesting sensation. There was only some part of the phenomena we just experienced. Okay. Let's move on to discuss the sound pressure level. Okay. Suppose I have one sound that has like, that is 1 kilohertz, 500 hertz. That is 1 kilohertz. Now you understand that, right? Okay, so when you hear some noise, what you can do is you just whistle, and then you can immediately see that the noise coming from, for example, fan is, the frequency coming from the fan is lower or higher than the 1 kilohertz that you can find out, right? So that is one good reference of frequency. Well, what I'm going to talk about is when I have a SPL1, that is 1 kilohertz. SPL1 is the sound pressure level of the tone 1. Okay, then that can be written as 10 log 10 p-square reference mean square average. And I say this is mean square average of tone 1. Then I can write that p square mean square average of tone 1 is what? Okay, 10 to the SPL1 divided by 10. Okay? You have some difficulty? Huh? Multiplied by p-square reference. Thank you. And if I have another sound pressure level, 2, at different frequency, then we can write this formula, and then mean square average of another tone 2 is simply 10 SPL2 divided by 10 multiply p-square reference. Okay? What if I hear these two tones together? Can you, why don't you whistle, Kim Gi-won, why don't you whistle some sound? Anything. And then I sound, and this is 60 decibel and this is 60 decibel. SPL1, SPL2. And what you hear is the sum of these two sounds. Now I want to calculate that in decibel scale. Okay? Then, what I'm saying, what is SPL1 add to SPL2? Okay. Then I can say SPL1 plus 2 is equal to 10 log 10 p-square reference and p-square average 1 plus p-square average 2. Okay, that, is it true? Okay. The proof can be found in our text. Now, this is true. Okay, then I can write that is 10 log 10. Okay. 10 SPL1 divided by 10 plus 10 to the SPL2 divided by 10. Right?